Hey, this is going to be commentary for chapter 39 of my book, Metadimensional, which you can find on Kindle or listen to for free as an audiobook on Google Play, and links are in the description. Chapter 39 is called Hello Experience. Now, I don't know if you know anything about computer science, about programming, but usually the first thing you do to learn a computer programming language is to write this kind of application that's called Hello World. All it does is display Hello World on the screen, which is not a lot, but in itself, like the function is not meaningful. But by doing that, you learn how to write files, how to run them, how to compile them, how to make like a file on disk become something that you can execute, and yada yada. There's lots of stuff, and it's a good way to just have a first stab at programming. And after you do that, you make small changes, and by making small changes, you see how you can you learn the language further, and you learn the paradigm further. And I think so. This chapter is trying to do that, trying to do like this first stab at this project, not as a real programming exercise, but more as a thought experiment. Like there's so many things about that need, like that once you try to actually get into the weeds and understand how it works, become a bit like become open questions in themselves, and like they reveal some like things that you wouldn't know to ask or to think about if you didn't try to go ahead and try to implement it, even though it's a thought experiment, even though you're not running anything actually. I mean, for example, this isn't in this chapter, but why do we use neural networks in the brain? Why would we use neural networks? Is there a reason why a virtualized version of a sentience would use neural networks and not, let's say, support vector machines, or the other like machine learning algorithms other than neural networks? And why did evolution pick that one? Is it inevitable? Is there a reason? I mean, yeah, you can say. I mean, all the evolutionary explanations tend to be circular. Like, why is it simpler for us not to actually have neurons in a computer, but rather have like standard computer architecture with registers and CPUs, the same we have like in any other computer? Why did biology pick that seemingly more complex architecture? Is there a reason beyond because it happened to be like that? So there's a bit of a before you get to that, you discover something a bit strange about the brain, about the fact that it uses the fact that it uses neural networks. So what do neural networks do? So neural networks, what they do is they are trying to find an optimized solution for a classification problem, basically. Trying to find to be able to identify that with a good level of accuracy, whether some input matches some threshold or something like that. I mean, there's a lot that built on top of it, and then you have like things that used what was learned to extrapolate new data, but or new examples. But it's basically an optimization thing. Like it tries to get to the perfect computation agent or whatever, depending on the parameters. Now, why does that matter? Like, for example, to be best at understanding what the sentence meant to say and answer the most relevant, and to give the most relevant answer. Now, why is that important? Because, well, when you have like artificial intelligence, that works well. Like, it makes sense. We're going to have the answer that we want. But virtual intelligence isn't, as I said in the previous chapter, it's not a tool to answer queries. It is serving this internal agent, which is experience. And that agent has omnipotence in its domain. Like going back to the previous chapters, like what does experience do? Experience like gets to do metatemporal evolution, gets to choose the contents and the laws of nature of the wakeful world. So it gets to decide not just what matters to it in the sense of like in the semantic sense, but it also gets to decide what is the contents of the world in which it exists. There is reconciliation with other experiential agents, but not always are there other experiential agents to talk about, on a desolate island. I don't know. Of course, I'm simplifying. There's parabrains, but ignore that. So what's the problem here? So you have something that does optimization on it, and the other for something that has the capacity to do whatever changes necessary to get to whatever result it wants. So when you have these two capabilities together, when you add them together, you get to the understanding that the simplest solution would be for the experience to put this neural network architecture into a situation where it's always right, because it has the capacity to do that, because it's omnipotent in its domain, and that neural network is part of its domain. So why doesn't it do that? Why is the brain doing anything? Experience has the capacity to make it unnecessary for the brain to do anything, and everything would be hunky-dory, but it doesn't do that. So when you understand that, this wouldn't be like obvious if you didn't think that experience is fundamental. But once you understand that experience is fundamental, and then you look at the brain and you see how the brain is organized, what kind of algorithms it runs, then something doesn't add up. And yes, something doesn't add up. And the thing that doesn't add up is that reward function, the thing that determines what that neural network is trying to solve. Well, it's not part of the neural network. It's not something that is itself being optimized. There is the experiential component of our psyche, and it comes with free will. It comes with free will because it's causally independent, and because it is causally independent, because it's free, it's not optimizable. And that it kind of inverts our understanding of what the will is. The will isn't like to optimize. We think of the will. The reason we want this, the reason we want that, is because we're trying to optimize some kind of success of our species or whatever. That's not what the will does, and that's not what the will do in a virtualized setting. If that was the case, if the will was trying to optimize something in a world where the experiential determines everything, then it would have optimized everything. It would have optimized reality away. It would have simply said, I don't need to solve this because I can just decide it's solved. So we're talking about something irrational. The will is irrational, and if you're trying to virtualize the brain or virtualize the relation between the brain and experience, you're going to have something that doesn't make sense and doesn't lend itself to rational optimizations. And by that sense, it's also not something you can communicate with. It's not reasonable. The will, the thing that drives the intentional driver, our intentional driver, is not reasonable. It's not something you can communicate with. It's not something you want to communicate with. You're communicating with the neural network that tries to put reason in the chaos. But underneath, there's something that's not reasonable, and it's driven by let's say, what I suggested in the previous chapter, like archetypes or tendencies in the experiential script, something that experience tends to want more than other things. But that's on the level of the archetype. That's not on the level of the specifics. On the level of the specifics, it looks like chaos. So when we are interacting, like there's a lot of stuff that happens in the adapting layer between us. But me and you, we are two irrational, wanting agents. And the same would apply to any virtualization of ourselves.